Hey everybody, this is Larry. This is me going Q3 of the weekly contest 396, minimum length of anagram concatenation. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. I think this one I should have done much quicker, to be honest. I end up taking about 11 minutes, and really it's a little bit sad once I figured it out because it is just brute force. Yeah, because for some reason during the contest, and this is a little bit of just like being sad, I thought it was going to be binary searchable. I saw that it's going to be 10 to 5th. Binary searchable should make sense. But it turns out that it is not binary searchable. And you can it's very easy to see that it is not binary searchable because, for example, I mean, not even talking about the gaps because obviously the possible length of t has to be a divisor of n, where n is the length of the string, right? Even ignoring the gaps, it's just that you can have 4 and 6, and something could be good at 6 but not 4, just because of how numbers and multiples work. So anyway, I'm not gonna get too deeply into it. I don't know why I got a little bit confused about it, but to be honest, I don't know why this is fast enough, because when I looked it up, n is 10 to the 5th, and the idea here, that let me go over how I did it first. Here I take all the divisors. These are all possible lengths of t, I think they call it. Yeah, possible lengths of t, because these are the divisors of n, where n is the length of the string. So that it has to divide into them equally, right? And this is also an idea that you could kind of maybe say share with Q2, but yeah, the quick idea is really just that given a target length, we just take that chunk of the string and then see how many times each character comes up, and then compare it to the first chunk, because the first chunk has to, this is the same idea as Q2 kind of, right, where the first chunk is just the first chunk repeated in some different order, so you compare them in different order, but it still has to be like there's a border, if you will, in every length t, right, for some target. And that's basically what I have. So then here, after getting all the divisors, I just check to see if x is good. If x is good, we return it, and of course the last possible value is going to be n, so that's always going to be good. Maybe I should have an early termination on that, actually. Maybe that'll make it slightly faster. But either way, this is fast enough because the biggest, or the number with the most divisor is like 128 or something. That's what I'm told. I don't know. But it passes anyway, I suppose. I don't know. Right. So yeah. So that means that we do this loop 128 times, and this is linear time, and that's it. So it is going to be phi of n times n, where phi is the number of divisors in n, of n rather, not in n. So yeah, because basically this is O of n, right? There, I think it's phi, right? Unless I'm confusing things, but yeah. So this is O of n times phi of n, where phi of n is the number of divisors. If I mess things up, let me know in the comments. But the notation may be awkward, but the idea is going to be right. That's all I have for this one. I don't know. It's not very interesting. So the way that I did it, this is how, the square root of n. So this is less than n, so I don't worry about it. But in terms of complexity. But yeah, this target thing may look a little bit weird. The collection.can just basically puts them into a frequency table. So I get a frequency table of the first target characters, and then I also do it for every chunk of target characters. And if they're not equal, then return false, and otherwise you keep on choosing it. And then once this is returned true, then we're good. And that's pretty much it. That's all I have for this one. This is linear time, and over alpha space, where alpha is 26, because this is only up to 26 and this is only out of 26, and this is, I guess, all of phi of n, so that's the space limited. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest now. 1, 3. Anagram of some string T. Concatenation of anagrams of, okay. What does that mean? I mean, a lot of people submit and got wrong, so I don't think this is straightforward. What is a concatenation? Minimum possible length. Anagrams, okay. So it has to be a prefix. Can I do binary search? I don't think this is right, but that's fine. Let's binary search a little bit. Is it fast enough? Yeah, it is. Okay, fine. Okay. It's not quite as easy, is it? Oh, whatever. This is good, then we try a longer one. It's bad, we try a shorter one. Not mid, Larry, P of mid. Okay. 2, 4. That's not right. Because if it's good, we want to make it bigger, right? Okay. Why am I wrong? 4 is false. 4 should be true. Oh, what the? Am I doing this wrong? I am silly boy. 4, 1. That's not right. Why is it not right? 2 is true. Oh, minimum. So if this is good, we actually want it to be smaller. If this is not good, then we will try a bigger one. That makes more sense. What am I doing? That's not good. Am I misunderstanding this problem? It's just a prefix, right? One works. Well, does it though? One does work. The hidden case is going to kill me. Usually it's pretty obvious, but maybe not in this case. This is 2, right? What am I missing? Am I misunderstanding this? Minimum possible. Right, and n is what am I doing wrong? Is so oh, this isn't binary searchable, is it? I am dumb. Okay, then maybe that's just it. I am just being dumb. Well, no, don't delete all everything, but it goes up to whatever. It's not binary searchable. But what is the case where it's not? Because if it's prefix of, because if it's, what was my 4? No, there's too many factors to do it if it's not binary searchable. Why would binary searchable? Is it? Okay, so no, this is definitely not right. It's binary searchable seems weird. It's not binary searchable. Why is that a hidden case? Do they expect it to be? I don't think it's binary searchable. I don't know why I didn't think about it though. I'm just looking at the highly composable numbers. 128. 128 times this is a little bit too slow though. Maybe. I don't know. guess we can try it. Right, so that would be the answer, but what if I have I have to get like a so the biggest number is like 8. Is it something like this? That's pretty fast, actually. So I guess maybe we'll give it a try. I don't know. Let's do one more thing first. $128. Okay, fine. If they think it's fast enough. YOLO. I thought it was binary search, to be honest. I really thought it was. I mean, yeah, okay. Focus on this one. We'll talk later. Silly Larry. How many people got that one? 388. I guess if it's a folder, mod. Yeah. I guess if it's a folder, people would get it. I just didn't think it would be that easy. Hey everybody, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.